Hi, my name is Jackson Koenig, and this is my video on how and where silicon and zinc formed in the fusion of stars. Alright, let's talk about how fusion works. Fusion is a process on which the inside of a star combines one nuclei of an element and another nuclei of an element, and they combine into a whole new element. This whole new element doesn't just come from them just happen to run into each other. It comes from the insane heat and energy that is compressed inside the core of a star. And that type of fusion reaction emits insane amounts of energy, which powers thousands of miles of radius of stars, which means, yeah, it's pretty powerful. All right, the energy formed from fusion obviously doesn't just teleport off into space and just fly out. No, it has to travel. And there are basically three main steps to this process. The first step would be due to the photons flying out of the core, emitting that energy, basically acting like a power source for the core. These photons not fly out, they slowly, very, very slowly, inch their way out of the core, and while powering the star, they exit the core. Second step, that would be convection. Convection is basically like here on Earth, under the crust, there are processes in which the hot air, the cool, less dense air, the hot, less dense air floats up, and the more dense, cool air sinks down in like this continuous circle, as you can see in this picture here. This circle allows the energy to travel more fluently. And keep in mind, this process is extremely slow, like thousands to millions of years slow. And the third process would be conduction. And it's also like conduction, electricity, conduction. The electrons smash into each other, creating more energy, allowing to create more power to fly through the star, to inch through the star. And eventually, once all of these processes go through their time, and they do their time, the energy will flow out through the surface, and it will go off on its vast journey across space. All right, now we're gonna get into our first element, silicon. Silicon has an atomic number of 14. This element is a little bit lower on the periodic table, which means it is created in a large star. And large stars are huge, like really, really big. Like compared to me, it would probably be around billions, trillions, maybe even quadrillions bigger than me. I don't know. But it is unimaginable how big these stars are. And for this element to be even created, it has to basically be dead. So it goes through the main sequence. This star goes through the main sequence, and then once it starts to die, the gravity will overtake the outward pushing of the hydrogen flow in the star. So the hydrogen is depleting, and the gravity is winning. So the star is collapsing. And when it collapses, when you put your hands together and you push hard, it creates heat and pressure, exactly how the star is working. The star is compressed in, and that compression allows for that more fusion to create our friend silicon. And silicon, once all that fusion happens, it's a little bit of a more complex element, so it releases a lot of energy. And then that mass finally overtakes gravity again and starts expanding, getting even bigger. So that huge amount of mass can shrink in to create one super hot and pressurized space for silicon to form. And then once all that energy is created, it'll expand out, overtaking the spherical shape of a large star, and finally start winning against gravity. But silicon, we are talking about the pure element of silicon. Silicon here on Earth can be used for construction elements, transistors, solar cells, computer chips, all that stuff. But today we are talking about the pure element of silicon. Silicon can only be created in large stars because of that huge mass shrink. It'll create that pressurized space, allowing for the silicon to be created. That is why small stars are not able to do this. Small stars do not have that type of power and mass to be able to create such a pressurized and hot space. It is not able to create silicon. Not whatsoever. It is only created in large stars and supernovas, but we will get into that later. But for now, we will realize that small stars and medium stars do not have the power and mass to create silicon. All right, now we are on to our second element, zinc. Zinc, with the atomic number of 30, also has many uses here on Earth. But today we are going to focus on just the atomic little atom of zinc and how and where it's created. Zinc, that will also be created in a large star, but not just a large star. It'll be at the very end life cycle of the star, right as it creates this thing known as supernovas. Supernova. That is basically when the star compresses so much that it can't handle itself anymore. The outward pressure is too much and the gravity cannot win, and it is too powerful that it explodes outwards and create this ornate array of every single element all the way up to uranium. Basically every single element that is not man-made is created in this ornate blast of many different elements. And that is basically where zinc is. But supernovas is when this large star, like I said before, it shrinks, grows, shrinks, grows, shrinks, grows, and it goes on for this process for billions of years. But at some point, gravity will overtake it, and gravity will shrink it down, and once it gets to the core, it won't be able to hold itself anymore. The gravity will squeeze it in, and the outward mass will push out in this one instantaneous explosion. This supermassive explosion will leave zinc, every single element, all the way up to uranium, floating out into the vastness of space. All in all, these two elements, zinc and silicon, are both pretty complex elements and have to be created in pretty specific conditions for them to even exist. For example, zinc, in this huge ornate explosion of different elements, elemental dust everywhere, and this other element, silicon, has to be created in one giant ball of fire. If you ask me, that sounds pretty specific conditions. But they also can be created here on Earth, but for our case, we are only focusing on how they are made in stars. And yeah, for example, a small star cannot create it. It cannot create either of them because it does not have enough heat and pressure to create those specific conditions for them to be made. Along with a medium star, not enough mass, not enough gravitational pull, pulling them in, creating all that heat and pressure, and not that explosion to even think about creating it. But yeah, that was my video on how and where silicon and zinc were formed inside of stars. Thank you.